Hello guys, welcome back to our YouTube again with another video. Today I'm going to explain you all about how is the circuit made for CC's characteristics experiment, lab experiment, or also it is useful for your theory examinations point of view. So let's have a look at here now. So this is the CC characteristics lab experiment. So what is the role of every passive element and active element? Let's have a look at it here now today. So keep it understanding. So let's start the video. So here 0 to 30 volts of VBB is used. VBB means RPS. RPS means regulated power supply. Here also the arrow shows the variable power supply. Variable means it can vary from time to time as our wish. We can vary the voltage from the voltage source. So here the variable voltage source is from variable voltage is from 0 to 30 volts. So this is a circuit diagram of CC characteristics experiment. In this we will use BJT here. BJT, uh, the common collector experiment. The collector is connected to the ground and is common for both emitter and base. So it is said to be as a common collector experiment. So here we will use resistor here to resist the current flowing from this charge to red. If the current is somehow small, more somehow so much small more than the required voltage in the cutoff voltage, the device will be busted out. So here we will use resistor so that the device is stable and clear. Here it can measure 0 to 200 milliamperes. So if the current is more, the the transistor would be destroyed. So we are using here resistor now. Resistor, this is the flow of current. It acts like a narrow pipe. When water is flowing through this narrow pipe, it has some resistance and it starts to flow some slowly from there and again starts to, and its velocity decreases for high pressure. So same in that way only, the voltage is more, velocity will be decreased, and the flow of current is not left unchanged, but the here readings are noted down in the ammeter here. So here is the readings are noted down in the ammeter. Next, positive of the ammeter is connected to positive of the voltmeter, because if we connect a negative to the positive, positive to negative, the readings will be wrong. The readings will be coming wrong. So we must connect the uh, this positive to positive, RPS positive to ammeter positive, and RPS positive to voltmeter positive, and positive of ammeter to voltmeter positive. This acts like a common point here. So here is the common point here. Next, yeah, here voltmeter readings are from 0 to 20 volts. VBC. VBC means voltage of base collector junction. So this measures the current reading in the first circuit, and this measures the volts in first circuit. This measures the amps or current in the second circuit. This measures the volts in the second circuit respectively. So here also see negative is connected to negative, positive is connected to positive, so that there is no distortion or there is no negative readings. If we are using multimeters, there is nothing will be happen to the multimeters, but we use analog meters, the meter will be busted out or it shows a deflection in the reading, because negative reading is not shown in the analog meters. So the analog meter may not work properly if the connections are wrong. So be careful about that and use the lab experiment apparatus carefully so that it won't be destroyed. So here is the emitter. Always is current flow. Current flow is electron flow. is always in the negative direction of emitter. But conventional current flow says that the current flow is through the positive charges, that is that holes. But it's not real in the practical cases, because it's not the current carriers or positive charges or holes. It's the electrons which are charge carriers. So here collector collects the electrons flowing from the base. Here this electrons will come in this way and reaches here. So this this will become negative, and this positive will become negative, from positive to negative here. So here also see the current flow is from negative to positive. So it's in opposite direction to the emitter's arrow. But you shouldn't mention like this, because in analyzing of circuits we won't mention it, because the conventional current flow is opposite to the real life application of electrons and electron flow of charges in the circuits, in the real life applications, in amplifier or its characteristics experiment, etc., in the lab experiment practically. So here plus is from, so here electrons will come and this plus will become minus to here. So here holes are there, holes were there. So in that holes this electron will be filled, and rest will be coming in this way, so that it will become the rest here here totally filled up, so that it stops here only, and again here the negative electrons are applied, so that here energy, the electrons gain energy and starts to flow in this way, electrons flow in this way, and at last it will attract to the positive of the RPS. So this is the current flow and conventions of polarities of BJT in this way, from positive to negative and negative to positive in this way. So this is about CC characteristics experiment, and how the circuit is designed, and what is the real life applications of circuit. And in the real life we can understand the circuit CC characteristics as an amplifier in the active region only. Active region only when RC, no, base collector junction is reverse biased. Mainly biasing is more important, because biasing only states that it is in the active region or passive region, active region, saturation region, and depletion region. So this is all about the uh, CC characteristics experiment. So you can understand it very well. I am explained it everything very clearly. Here also base emitter is junction is forward bias. So this is all about the CC characteristics lab experiment, circuit diagram, how circuit is designed, and what's the importance of each passive and active element. So I have make you understand in this video. In the next video, we'll understand what is the importance of the C amplifier circuit and C characteristics experiment. Thanks for watching, friends. For more interesting videos like this, please subscribe to my channel, hit the like button, hit the bell icon, and activate the notification bar. Thanks for watching, friends. Bye.